Hello learners and welcome to this session. This is Form 4 Mathematics, Matrices and Transformations. In this lesson, we are discussing the inverse of the matrix of transformation. I'm Teacher Sharon. By the end of the lesson, you should be able to find the matrix of the inverse of a given transformation. A transformation matrix that maps an image back to the object is called an inverse of the matrix. Note that if A is a transformation which maps an object T onto an image T prime, then a transformation that can map T prime back to T is called the inverse of the transformation matrix A and is written as image A negative exponent. So if R is a positive quarter turn about the origin, the matrix for R is 0, negative 1, 1, 0. And the matrix for the inverse of R, which is R negative exponent, is 0, 1, negative 1, 0. And this means that if we take the inverse of R, we multiply by R, we are supposed to get 1. Let us look at the given example, and we are told T is a triangle with vertices A, 2, 4, B, 1, 2, and C, 4, 2. S is a transformation represented by the matrix 1, 1, 0, half. A, we are supposed to draw T and its image, that is T prime, under the transformation S. And for us to draw the object and the image, we have to get the coordinates of the image. So we take matrix of transformation times object coordinates to get the image coordinates. So we are given the matrix as 1, 1, 0, half. We have the object coordinates as A, 2, 4, B, 1, 2, and C, 4, 2. Now we want to get A prime, B prime, and C prime coordinates. So for the x coordinates of the vertices, we take the first row, we multiply by the columns. So the first row times the first column will be 1 multiplied by 2 plus 4 multiplied by 1, which is 2 plus 4, giving us 6. So the x coordinate of A prime is 6. Then we go to the first row times the second column to get the x coordinate of B prime. So we have 1 times 1 plus 2 times 1. So this is 1 plus 2, which is equal to 3. For the C prime, we take the first row multiplied by the third column. So we have 4 times 1 plus 1 times 2. This is 4 plus 2, which is equal to 6. So the x coordinate for C prime is 6. For the y coordinate, we take the second row. So we have 0 times 2 plus half times 4. So this is 0 plus 2, which is equal to 2. So the y coordinate of A prime is 2. Now we take the second row times the second column to get the y coordinate of b prime. So we have 0 times 1 plus 2 times half, and this gives us 0 plus 1, which is 1. So the y coordinate of b prime is 1. Now we go to c prime, where we take the second row times the third column, that is 0 multiplied by 4 plus 2 multiplied by half, this is 0 plus 1, which is equal to 1. So we have the coordinates of the image, that is a prime is 6, 2, b prime is 3, 1, and c prime is 6, 1. Now we can plot these on the grid which is provided. So we start with the object where a was 2, 4. So 2 for x and 4 for y. So a will be there. Then b 1, 2, it will be there, that is b. We have c, which is 4, 2. Now we join with straight lines to make a triangle. And that is the object t. Now we draw the image, which is t prime, and we have a prime as 6, 2, that is a prime, b prime 3, 1, and c prime 6, 1. We join with straight lines. And this is t prime. So we've answered question A. In question B, we are told to find the matrix of the inverse of the transformation S. So from definition, we said that if A is a transformation which maps an object T onto the image T prime, then a transformation that maps T prime back to T is called the inverse. So now the image will be acting as the object, and we use the formula matrix of transformation multiplied by object should give us image. Note that the object will be replaced by the image, and the image will be replaced by the object. So let the matrix be a 2 by 2 matrix, which is A, B, C, D. Then we multiply by the image, which is 6, 2, 3, 1, 6, 1. And this should give us the object, which is 2, 4, 1, 2, 4, 2. We can form simultaneous equations and solve them. So we have the first row times the first column to give us 6a plus 2b equals to this first term, which is 2. The first row times the third column, let me pick the third column, that is 6a plus b equals to the third x coordinate, which is 4. I subtract equation 2 from equation 1, and this one is 0. This is b is equals to negative 2. Now that I have the value of b, I can substitute it in equation 2 to get the value of a. So I have 6a plus negative 2 is equals to 4. This means that 6a minus 2 is equals to 4. 6a is equal to 2 plus 4. 6a is equals to 6 by 6 by 6, and the value of a will be equal to 1. Now for c and d, I take the second row times the first column, that is 6c plus 2d equals 4, and then I go with the third column again. I'll have 6c plus d is equals to 2. Subtract equation 2 from equation 1 and we'll have 0 for c. D is equals to 2. So the value of d is 2. Substitute in equation 2 to get the value of c. 6c plus 2 is equals to 2. This means that 6c is equals to 2 minus 2. 6c is equals to 0, meaning the value of c is 0. So the matrix represented by A, B, C, D will be 1 for A, negative 2 for B, C 0, and D 2. So this is the matrix of inverse of the transformation. Thank you for listening. That is the end of this lesson.